Welcome to my channel. We are continuing our video sequence on integration by parts, and today we have the following problem. You can access the link with all of the videos on this topic in the description down below, and we'll proceed for now. Alright, some of you may already see that we'll use integration by parts multiple of times here. It's because we have x to the power of 5, polynomial and exponential part of this integral. And as I did in my previous videos, we'll use the reduction formula to do this, to skip the tedious calculation of each of these integrals. And we can write this integral as I5, where In will be equal to x to the power of n e to the minus x squared dx. We can write this integral as x to the n minus 1 multiplied by x times e to the minus x squared. I didn't do something special here. The product of these two will be x to the n. Why I did so? To take the x times e to the minus x squared as the function will find an antiderivative of, and as always we'll use the polynomial as the function will differentiate later on to reduce its degree. Now, for those of you who didn't really get why do we need to write x times e to the minus x squared to find its antiderivative, I'll explain. If we see the exponential function, we know that its derivative will be preserving its structure. Namely, it will be e to the u multiplied by u prime. Now we want to find an integral of e to the minus x squared. Let's just first see, if we get that function, the antiderivative, what will be its derivative? If you have minus x squared, its derivative will be e to the minus x squared multiplied by derivative of minus x squared, which is minus 2x. So basically we have minus 2 times x times e to the minus x squared. Now from this we see that if you have integral of x times e to the minus x squared dx, it will be e to the minus x squared over minus 2. It's because we can put minus 2 out of an integral, while we cannot do so for the function, which is x in our case. So that's why we want to obtain the form of x times e to the minus x squared, so that we can integrate it later on. Okay, I hope this remark is useful for you, because you will use this lots of times when you are dealing with such an integrals, and it will be very comfortable to remember that for e to the minus x squared. Let me just make a remark here that integral of x to the e to the minus x squared dx is equal to minus 1 over 2 e to the minus x squared. Right? Just take this derivative of this function and you'll obtain x times e to the minus x squared. Alright, I hope everything is fine until this point. Now let's apply integration by parts. Well, again, I'm taking this as our function f and exponential part as the derivative of some function. Okay, in integration by parts we want to obtain the form fg minus integral of f prime g. Now let's see this in terms of our functions. First we just rewrite f, which is x to the n minus 1, and we multiply this by antiderivative of g prime. We already know that it's e to the minus x squared over minus 2. We subtract the integral of, we just rewrite what we found as a antiderivative of g prime to the minus x squared over minus 2, and we multiply this by the derivative of our function f, which will be n minus 1 multiplied by, let's make it in a little bit compact here, still not enough space, well, that will be just perfect, x to the n minus 2 dx, just the derivative of polynomial. Alright, let's write it in a more neat way. What we have is x to the n minus 1 times e to the minus x squared over minus 2 plus, since we have minus 2 here, and we know that n minus 1 is a constant, minus 2 is a constant. We just can write this as n minus 1 over 2 integral of x to the n minus 2 e to the minus x squared, right, dx. Alright, and this is indeed x to the n minus 1 e to the minus x squared over minus 2 plus n minus 1 over 2 I of n minus 2, right? Just note that this is equal to in minus 2. It's just how we defined our in. Alright, we already have a reduction formula for in. Remember, it was all equal to I of n. Now, for the sake of convenience, let me just write it here, that in is equal to the n minus 1 e to the minus x squared over minus 2 plus n minus 1 over 2 I of n minus 2. Okay, now let's move to computing our integral. We know that we need to find I5, and we can do this by just plugging in the values of n, and we start from 5. Let me just rectangle it. Alright. Okay, I5 is x to the 4 e to the minus x squared over minus 2 plus, now 4 over 2 I3. Okay, it's minus x to the 4 e to the minus x squared over 2 plus 4 over, just 2 I3. Now we put n equal to 3, which is x squared, right, e to the minus x squared over minus 2 again, plus 3 minus 1, it's 2 over 2 I1. Okay, it's equal to minus x to the 4 e to the minus x squared over 2. We just cancel 2 here, and we are left with minus x squared e to the minus x squared plus 2 times I1. Now it remains to calculate I1, and we can do this from the definition. Let's make it as a remark here. I1 is equal to integral of, let's see what was our in. In is x to the n e to the minus x squared dx, which means that I1 will be x times e to the minus x squared dx. So I1 is x times e to the minus x squared dx, and we already know that it's e to the minus x squared over minus 2, right, and plus some constant c. Again, I'm reminding you that if we take a derivative of e to the minus x squared over minus 2, we can obtain x times e to the minus x squared. Okay, so our integral is, we are here currently, it's equal to, well, I'll just copy this thing to not lose time, and plus 2 times, we open up the braces, e to the minus x squared over minus 2 plus c. Okay, now let's collect all the terms and see what we have in the end. Minus x squared over 2 minus x squared e to the minus x squared plus, well, minus, right, e to the minus x squared, and plus 2c, and later on we'll just replace this by some c prime for the sake of convenience only. Now we already have our answer, it's this, but I prefer writing it in a better form. Let's just see what we can do here. Alright, we can take out e to the minus x squared, or even e to the minus x squared over 2, or even minus e to the minus x squared over 2, so that we are left with x to the 4 plus 2 times x squared, right, and plus 2. Let's see if everything is fine. Yes, this is equal to this, so it's fine, and plus some arbitrary constant c prime. Well, yeah, here c prime is equal to 2c, 2 times c, but it's not important since c is arbitrary, then c prime will be arbitrary as well. Okay, it's our final answer, and as always I'll rectangle it. Okay, here it is. If you have any questions, please feel free to write them in the comment section down below. I'll try to answer all of them. And here is the brief overview of what I did. If you don't have time to watch all the video, you can just look here. See you on the next videos.